This is Math Department Team Alpha, checking in from the loveliest village on the plains, Auburn, Alabama. Here at Auburn, we love our traditions, and one of our most unique traditions is the rolling of Toomer's Corner. According to auburntigers.com, the tradition of rolling Toomer's Corner is said to have begun when Toomer's Drugs had the only telegraph in the city. After Auburn University would win a football game on the road, employees of our local drugstore would throw the ticker tape from the telegraph onto the power lines. At some point down the line, Auburn fans joined in by throwing toilet paper, and the rest is history. Teams at the Auburn, Alabama Hackathon competition were prompted with several suggestions, one of which was to take advantage of the live feed of Toomer's Corner provided by the city of Auburn. What started as a joke amongst our team of mathematicians quickly turned serious. Using a little bit of calculus, we can programmatically identify when Auburn's famous corner is littered with celebratory TP. A quick Cal 3 refresher. Given a function of two variables, the gradient vector field always points in the direction of greatest change. As a result, a gradient vector will always be perpendicular to the corresponding level curve of the function. The function we wish to consider is simple. Using the well-known canny edge detection algorithm, we may isolate the edges found in a photo of Toomer's Corner. Now in this image, the corner has not yet been rolled, so the edges and normal gradient vectors are not oriented in a common direction. However, once Auburn fans get to rolling the corner, due to gravity, the vertical strips of toilet paper introduce numerous vertical edges, and therefore horizontal gradient vectors. By summing up the number of these almost horizontal gradient vectors, our application can say with a high degree of confidence that Toomer's Corner is currently being rolled. Our application does the obvious thing. It sends out a tweet to @istoomersrolled and updates our website, istoomerscornerbeingRolledRightNow.com. Despite the silliness of our concept, our application was met with a high level of excitement from the Auburn community, including the judges of our regional competition and local press. Following our selection to move on to the global competition, we put the app into production using Amazon Web Services EC2 cloud servers, where it watches the Toomer's Corner webcam 24/7 for that next rolling. We look forward to serving the Auburn community this fall as football begins, but we're also excited to celebrate non-football victories, which result in the Auburn family rolling Toomer's Corner as well. Of course, as this tradition is certainly unique to the Auburn community, we struggled to figure out how to generalize our application for global use. While there are certainly some other specific applications, we came to ask ourselves, is there another mathematical tool we can use to recognize arbitrary, unusual activity from a video feed? Another quick math lesson. Given a collection of data points in a two-dimensional space, the line of least squares regression may be used to identify where further typical data points are expected to be positioned. This technique may be generalized to 3 dimensions and higher, known as principal component analysis, or PCA. And that's a good thing, because a 400 by 300 pixel photograph is essentially a 120,000 dimensional vector. By using footage of a typical day at Toomer's Corner, we may use this technique to identify a hyperplane of least squares regression, capturing what you could call typical states of the webcam feed. Using this hyperplane, we're able to identify any not-so-typical scenes simply by computing the Euclidean distance of a photo from the hyperplane of typical photos. PCA is used in facial recognition techniques, but we see it being used in reverse here. By registering when a photo of an intersection does not look familiar to the algorithm, drivers could be alerted to find an alternate route to avoid the unusual activity being observed. While this application is still a prototype, our team is excited as this approach can recognize arbitrary strange activity for any video feed, rather than the specific criteria we search for in our production Toomer's Corner analysis. Thanks for considering our project for the Smart City Hackathon. We're honored to have had this opportunity to use mathematics and technology to improve our local and global communities. Be sure to check out our project readmes on GitHub to learn more about each component of our applications. And to our Auburn family, War Eagle, hey!